On the first part of this video, we started to implement an Helm package to handle the DAST format, which is a format used by DatoCMS for its rich text editor. So what we started to do is implement the different types that we will need to implement the format inside Helm. And once the types were defined, we've started to implement a decoder to parse a JSON document, a JSON DAST document. So we have implemented almost every node, some inside the part 1 video, some afterwards because it was not interesting to record it. But there are still 3 types of node: the list item, the inline item, the item link, and the block node. So in this video, we will implement the block node. So let's have a look. Remember, inside the rich text editor, the structured text editor of DatoCMS, we can add custom blocks, which are user-defined, so you can add every field you want inside those blocks. Here I have only 2 fields, which is an image field and a boolean indicating if the image should take the full width or not. If you have a look at the GraphQL result, you can see that we have this new type of node, which is a block node with an item ID right here. And we have outside of the DAS document, which is right here, outside of this document, we have a list of blocks with the content of the block, and we can find the block ID also. So let's implement that. So as we've done before, let's start with the types. So we need a new type of block, which is only on the root, if I remember correctly. Yeah, it's only a direct child of the root node. So let's start that. So root node, which will contain a block node. Sorry. Okay, let's create a block node. Right here, type block node equal. So we have a block node, and remember we have a block ID. So let's create that. It was a simple string, so let's just create a string, and we need the block content right here. So as it is user-defined, we cannot know what kind is it, so we need a type variable right here. So a block node of type A is a block node containing a block ID and this type. So here we will need to have A right here, and we need to add it everywhere. So let's add it right here and here. Okay, so now I expect it to not compile, which is exactly what is happening. So we will need to change every structured text right here. Okay, maybe do it manually to add a new type parameter, sorry. So let's add this type parameter everywhere. Okay, I think we're good inside this file. Let's see. No, everything compiles, so it's fine. We don't need to change anything else. Now remember we have 2 parts inside the GraphQL result. We have this list of blocks, so we will need something to decode this list of blocks, because the decoder we have right now is only for the document, the DAST document. Okay, so let's create a new method called a block decoder. So let's create a block decoder. Let's call it block decoder. Okay, and it will return a block, no, a block ID and A, which is the content of the block. Okay, we will need the constructor of that. So let's use the debug.todo. Okay, so let's test this method. So going into the text. Okay, so we have this describe with all the tests. Okay, oh, this should not be here. This should be at the end of the file. So we have the first describe for the first method, and now we need to have a second describe for the block decoder with our test. Let's copy and paste this test. Okay. Oh, I didn't copy it. Okay. So should decode a block. Let's call it an image block, and the input this time is only this block, so this one. Okay. And the result will use this time the block decoder. Did I export it? I'm not sure. Block decoder, no, it's not exposed, so I need to expose that. Okay, and now the result should be equal to block ID with our ID, and we should have the block content. So we need to create a custom type because remember it's a user-defined type. So let's say that we have an image block, which is an alias, and it contains the image URL, which is a string, and the format, which is image format, and it's either full width or image width. Okay. Yes, so here we can create the image block with this URL and full width. Okay, perfect. This test is not passing because we have a debug to do. So let's implement it. Right here, we will first need to decode the ID, so decode field. No, it's just the ID, sorry. ID, which is a block ID decoder. Okay. So let's create that. It's only a string that we will map inside the block ID, so okay. So we decode this, and we will need to create a tuple with that. So first part of the tuple is the block ID, and for the second part, we don't know how to decode it because it's user-defined. So we will need an input from the user, which is decoder of type A. Let's call it block content decoder, and we will need to use that to have the second part of our tuple. Okay, perfect. Does it work? No, because we've added a new argument. So here we have an error. We should give it an image block decoder right here. So let's create that, which is a decoder of image block. Okay. So it's map2 of, we need the image URL. So let's decode dot, so let's have a look. So the image URL is inside image and URL. So let's decode at image, then URL. It's a string. I'm better with that. And the second one, so it's a field. Yeah, it's a Boolean, and we need something more complex. So let's say field width and image format decoder. Okay, so we will need to decode the Boolean, and then if it's a full width, then we will return full width, else we will just return image width, if I remember correctly. It's only a map because it cannot fail. And here I just need a single field name. Perfect, so our test is passing, so I think it's okay. I guess we don't need another test on this decoder. Let's try to decode a document with a block. So here, should decode a document with a custom block node, and we will replace the child by this child. I don't know how to plug in that correctly. Yeah, better. So now we need to check that it will decode inside a root block, which will contain a block node. This block node, so let's import it, should contain a block ID with this ID, and it should contain our image block, so this one. Okay. Does it work? Yeah, okay. It compiles. Now we need to make it work. So right now we are not handling the root node, so let's go to here. And then we have our decoding decoder. Yes, right here we will implement this new kind of node, so which is a block node, and let's map it with a node, block node decoder. We can create that right here. Block node decoder, it's a decoder of block node. Remember, we have a type parameter. To decode that, we will need, of course, a list of block ID and a list of blocks. So we have a list of blocks right here, and for now we can keep that. So where is it? Let's go to the next compiler error. Here we need to give it a list of blocks. Those blocks should come as an argument. Remember, it's a list of block node, block ID, sorry, A. And of course, we need to propagate this argument right here. And of course, right here. Okay. Now, of course, nothing compiled, so we need to fix everywhere. So not here, but here. Let's go to the top of the document, and we will need to change every call to the decoder to add an empty list. Okay, here in the case of our last test, remember the custom block decoder, we need to pass it one block, so with the block ID and the image block. Okay, so okay, now we can start to implement as everything compiles. Okay, so block node need, what does it say? This is not a valid JSON to do unstructured text. Okay, yeah, it's because we have our debug to do. So right here, what we need to do is decode the ID, which is inside the item field. So it's let's say block ID decoder. So we have our block ID and then decode and then block ID. And now what we need to do is find this block ID. So here we have a tuple of block ID block content. Well, we don't care about the block content. Here I will just rename that block ID to find, and what we need to do is find where the block ID equals block ID to find. Okay. What am I doing? While triple equals. Yeah, of course. So I need to find that. So here we have a maybe. So what we need to do is map. So we have the block ID and the block content that were matched. And we will just create a block node with the block ID and the block content. And if it wasn't found, so here it's we need to have a succeed, and here we will fail with the string unable to find a matching block with ID. And the ID, so it's a block ID, so I need to maybe create that. Okay. And we can just return the block ID. So let's add it. So what is the problem right here? So list A, B. Yeah, of course, I forgot to add the blocks to the call. So now it's okay. And this one, no, it's not map, it's with default. Okay, perfect. It compiles. No, it doesn't compile because I've not imported the block node. Perfect. So our test is working. I will just try the case where it fails. So right here should fail to decode an image block if the block is not provided. So right here we will do exactly the same, but instead of no, it's not there. Okay, let's keep that. This is not the test I wanted to copy. It's this one. So right here should fail to decode. So here we won't give it any block, or maybe, yeah, no. Let's make that obvious. Okay, and we should have an error. I guess I don't know what the error will be. So let's say okay. How did I check the error above? I think I've done something wrong. Yeah, let's keep it that way. I think it's a bug in the extension. Should reject, okay, case result off. Perfect. I think it will not be a good error, so let's just have a look. So the error is field document, field children, index 0. Okay, this is exactly what we wanted. So error, yeah, and 1, 2, 3, 4. There should be an error. Let's see, finding that the block was not found. Okay, perfect. So we can remove the debug.log. Small tip, if you want to use debug.log in your test, because ntest doesn't allow it, you can use ntest rs right here by Mathieu Pisenberg. Really nice tool because you can now debug your test very easily. So everything is okay. I've implemented the block node. So now we will need to implement the item link, which is kind of a mix between a link and a block node. So it's a link to a specific item. And the inline item, which is kind of the same of a block node, but inside inside other elements, for example, inside a paragraph or something like that. I won't do that on this video because it's nothing new. I will just do the same things that I've done for the block node. In the part 3 of this video, we will start to implement the structured text to HTML function to transform this structured text into HTML nodes and display it inside all web pages. So thank you for watching. I hope you liked it. If you don't want to miss the part 3, you can subscribe to my channel. And if you like this video, please leave a like or a comment. Thank you.